Hey, good morning, everyone. So we still have like 4 or 5 minutes. So let me know if you have any questions before we start. No question. So you are all done with lab 0?
Yep.
Good, good, good. Sorry, what was that? Okay, nothing in the chat.
I had a question with the first question on lab 1. Is that fine? Just
Yeah.
I wasn't sure. It didn't say anywhere how we're getting the inputs for like the for loop or anything, or how many we are getting.
Yeah. So that if you read the question, there are no inputs, right? Because it tells you, I guess, if I remember this question specifically, it's 400, I guess, something around this. So basically the question itself tells you what is the number of iterations. So you don't need to get any input from the function itself, right? This is why the function takes no input. So let me look into the question to give you the exact number.
Was that one retailer?
Okay, so here. Yeah, so it computes the sum of all numbers that are multiples of 4 between 30 and 1,000, right? So that's why the function takes no input. You don't need any input from the user or input to the function to compute the value in this question. But,
Oh, I misunderstood. Yeah.
okay, that's okay. Let me look into the chat. There were a couple of things here. Do you prefer our usernames to be our Mac ID? I know that some of you already modified this. It doesn't really matter as far as you are using your Mac email in the account. This is what matters. But in fact, it would be better. Something that I forgot to say very clearly in Lab 0 document, and this is why I'm not going to penalize, but you are asked, there is a README file. Once you open your GitHub repository, you were supposed to see this README file that asks you to input your.
And then just chaos, right?
Can I
At least
ask
with
you all
Microsoft, it
to
seems
mute?
like they're trying to schedule this thing out, and they released an entire page detailing all of this time, when you can do it, and where you can pre-order, and even where you can do Xbox All Access. So let's go to the page here.
Okay. So yes, I would prefer that, but that's not a problem at all. And usually in coming labs, you will be asked to modify this README file to enter your username and section number, as well as your numerical ID, such that it's easy for us to grade it. But for Lab 0, don't worry, that's okay. If we have the check mark, I will come into this question once we start, so don't worry about this. Question: if you pass all the non-hidden tests for the lab, does a check mark appear in the Git repository, or do you have to pass? No, yeah. So that's a good question. So, and what is hidden tests? Because maybe some of you didn't like hear this in the lecture or so. So basically, the way we run the labs is we give you some tests to be able to run locally to check your lab correctness, and you are also asked to enter or code some of your tests as a double check. Good. But as you might imagine, not all questions will have 100% coverage in tests, especially if it's an involved one. The add is not a big deal because it's just a single line. And this is why we didn't bother much in Lab 0. I was more concerned in the environment. But later, in subsequent labs, there might be a case that you pass all the tests that are given to you, but in fact, you still have a problem in your code, right? Because the test is only testing the case that it provides the input to, right? For example, if all the tests are providing positive integers, while you have a problem with handling negative integers, then the test will not expose that, right? This is why also you are encouraged to think of, and this in mentality is the important thing. And in internships, most companies are focusing on this, right? Once you write a piece of code, you need to have the mentality to think of what are the corner cases that can stress this code. And we will discuss this more when we advance in the course, right? But when you add a test, think of what might be this test doing, right? For example, if we have tests that are testing positive thing, then add negative numbers, add zeros, add a very big number, very small number. So try to think of what might be really this test is stressing, right? Going back to our topic, we give you some tests, and then we also have some tests that we have internally in our machines, like between me and TAs. And once you submit your lab, the TAs will get all the repositories and then do all the cross repositories checking that we were doing, that I talked about before, to make sure that there are no similarities across different repositories and across GitHub other repositories as well. This is an initial step. And then we run all the tests, the ones you got and the ones that we have and you don't got, and your tests as well. Any test that you have in your folder, we will run it, right? And then hopefully you pass all of that, then that's great. So this is kind of the background of what hidden testing. It's not hidden test, it's just something that we didn't give you, right? The check mark is only for the tests that you currently have, right? So it's like, for example, for lab 0, it's only the 2 tests we give you in addition to the 3rd test, which you have to make sure you add it to the test suite, right? So it only tests that the tests that you wrote in your code, and the check mark will be green. And I will go with you right now because I kind of discovered that maybe not all of you are able to check that. So I will go with you through the GitHub page now, but this check mark will mean that you passed all the tests you have, not the ones that we have internally. Good. How do I know if I have finished lab 0? I will come into this as well now. Where do we find the check mark? I will come into this. The only files we need to modify are questions.c and test cases.c, not test.c. I put a printf statement in my testing case, but after no, you shouldn't put any printf in your testing case. It only shows 3 results run correctly, but no anything printed. So you shouldn't be printing anything. So don't put a printf. In fact, it should print, but I don't know why, but like you shouldn't be putting any printfs in the test cases. The way the test case or the unit testing framework is handled is just prints things using other functions. Good. So let's now, given that you are asking about the GitHub page, I hope you are able to see the GitHub page, correct? Can someone confirm the chat just to make sure we are all on the same page? Okay, perfect, thanks. So I just open any repository, like for example, one. So this is, oh, sorry, this shouldn't be. So for example, let me do this. And then this. This is the page that you see in your repo internally. And because this is a repository that is shared between us as an organization and you, so we also see exactly the same thing, right? So what is here? Here you have all the files. And if you open any file of these, you will see your changes, right? But something that is very good about GitHub that I told you before is that it can tell you exactly what is the history. And for each commit you have done, remember you do a git add from our last tutorial, and then do a git commit to push to your local repository, and then a push to push things here in the remote repository, right? Then it gives every commit or every process, every push a number. And this is the number, the latest you have seen. So for example, in this repo, the last commit has this number and it was done 9 days ago. You see this green check mark here? This is the one that means you passed all the things you have. If you click it, it says all checks have passed. And in fact, it can give you even some details. So if you look into the details here, the step that is important for us is the auto grading. So if you open it, it tells you that all tests are passed. And then this is exactly the message you get from your Eclipse as well. Okay, 3 tests. And then it gives you these funny things, right? So so this is how you can check. If you have a problem, and we will come now to the case where you have, for example, you didn't pass for some of the comments, then this will not be as green and you will have this red X mark, right? So this is about the check mark question that you guys had. Then another thing, so this is what I would do if I were you, to double check that if everything is passed in my Eclipse, I push and then I look here to see if I really passed all the 3 tests. One problem you might find, for example, if you forgot to add your 3rd test into the test cases, if you look here, still you will have a green check mark, right? But if you look here, you will find only you passed 2 tests, which are the original 2 that we gave you, not your 3rd one. That means your 3rd test is not added to the test suite, right? So you need to make sure that you pass the number of tests that you are required to pass. In this lab 0, 2 we gave you, and 1, at least 1 you are supposed to add. You are free to add more if you wish. Good. So going back. So another very interesting thing you can see in Git is to look into the history of all your commits, how you have evolved your code over time. Here, for example, we have 5 commits, right? And if you click them, it gives you exactly the 5 commits with their numbers. The last one passed, the second before the last one passed, but then, for example, the 3rd one was failing here. And in fact, these 3rd ones, these are the ones that we created the repo in. So as you can see here that this is our own pushes or commits. But here it also tells you who committed. So this is your commit, right? For example, if you are working in a project, not something related to this course, but assume you're using GitHub for a project with a friend. You can also track who committed what to track a problem. Not even that. In fact, if you just look into here, there is a very, like that's the message you put, right? For example, here the message, you remember git commit -m, and then you give a message in a string. This is a message, and this message, if it's meaningful, it will help you. For example, here I just knew, I just opened this repo in fact the first time now, right? I just knew that this commit is mainly about updating the README. So if I click it, this is another interesting thing. GitHub, it tells you what is the change history. The red one is what was before and deleted, and the new one what is added. So you can even track what changes you have made in a certain commit. For example, here the Mac ID this was the template that is given, so he deleted it, and then he added his own. Perfect. And this is student ID and added his own. So this tells you exactly the changes that has been made, and that's something that is very beautiful. For example, if you have a problem, you are tracking with the TA, you tell him, I was passing the last commit, but now I don't know what changed my code. Previously, if you are working in your local machine, you have to kind of do Control Z or go back, or Control Y to go back and undo everything, right? To see what really didn't pass. But here, every commit has its own. Then you can, first of all, check what changes you have made that make you fail or pass if you check. And then also, you can even go back in history to make your repo exactly at the commit that was passing. So if, for example, you added some changes and those changes created a problem for you and you want to just undo everything, you can very easily go back to the commit that was passing, right? Good. So let's look into a case where, for example, there was checks that are failing. So here all checks have failed because I just want to show you what will happen if you are failing things, right? So go to the auto grading. You will find here, like originally we had 2 tests. The first one expected 6, but was 2. The second one expected 4, but it was 0. So it gives you exactly the message that is printed on Eclipse as well. And here you can check which test cases failed and which not. Good. Okay, let me stop here and take some questions. So the only files we modify. Question: what terminal do I pick after hitting the blue computer? Okay, so in Eclipse, it doesn't really matter much. I personally pick the local terminal. You can also pick the bash terminal. Any terminal type would work. If you are using Mac, okay, this takes us to another question, because some of you were using Mac. If you are using Mac, in fact, you don't have the terminal issue in Windows. So some of you mentioned this step that we have to install the terminal in Eclipse. Get us to a link that may be specifically for Windows. In Mac, Mac OS is a Unix-based operating system. So it has a Unix terminal by default, like it's a natural terminal. Windows, we don't have these Unix terminals. This is why we needed to install another terminal. In Mac, just open your regular terminal, go to the BAS where you have your repo, and you are good. You don't even need to install the Eclipse terminal. You can if you want, but it's not necessary. Let me see questions here. Does the check mark, please, because some of you, as I said in previous lectures, some of you answer questions. So if you have a question, put it in brackets as a question, write question in front of it. Does the check mark indicate a perfect lab? I have already explained this, I hope so. Just that you passed the test cases. Okay, question. Me and 2 other people passed the tests for lab 1 according to the terminal, but GitHub. Okay, thanks, Kurt, for this. So for lab 1, there was a problem with the make file. I'm going to fix today. So if you are passing in Eclipse, that's fine for now, but please wait. By today, I will send out an announcement. And I guess maybe you need to do a get bool to get the updated make file to make sure you pass in the GitHub. But don't worry about this for now. If you are passing internally in Eclipse, most probably you should be fine. It's an error in the make file. Yeah, okay, I actually already added this. If you pushed and committed your code, it's essentially submitted, right? Yeah, so I'll erase it. That's correct. So once you do the push, and this is another good thing about developing. So your development environment is exactly the one that you use to submit. So you submit naturally. You don't need to do any other step to submit. Once you push, you see things as green. That means you already submitted your lab, because as you have seen, I have access to this and I can see it, right? Whenever I run the project, it says error starting process launched failed. I'm not sure why. So, okay, so for these specific questions, Mohammed, please, can you go to office hours? Because I have been saying this, and I also, in the past 2 weeks, and I've sent an announcement yesterday, go to any of the office hours, you can share a screen and we can help you fix this problem. My GitLab says I authored and I committed. Is this okay? I'm not sure, Met Battle, if I get that question. So please, if you can clarify, I can help with that. If you still have issues and you feel you don't see, as far as you see this green thing in your GitHub page, that means you passed. If not, then there is a problem, I guess we need to fix. Do I need to commit README, and how? You don't commit specific files. Okay, that's a good question. So we modified, for example, forget about the README for now. You changed it 2 files, in fact, questions.c and testcases.c, right? But when you did add, by just adding everything, you didn't need to specify the name of the file. So if you modified README, do exactly the same steps: git add all, git commit -m something, and then git push. It should push whatever changes you have already made. If I do a git bool, does it replace everything in my local repo, or they will be merged? Okay, that's also a good question. If you do a git bool, and there are conflicts, so Git is smart in handling conflicts. For example, the case I was giving for lab 1, we are going to change only the make file. Hopefully you are asked not to touch the make file. You are only doing the development in the questions.c and the test cases. That means there will be no overlap at all, correct? That means if you are asked to merge, just merge peacefully and things should be okay. You will have both the changes of the make file we have done and your own changes to the other files. And that's the beauty of revision control, is that, again, collaboration is very easy made, right? I went to the office hours and I have a green check on the main page like showed, but when I click the README file, it has a red X. When I open it, there shouldn't be any red X in a specific file. I'm not sure if I get what you mean. So maybe, Karina, we can look into it together in an office hour. But if the TA said maybe ignore it, then that's okay. If you are already passing the green check mark. Okay, good. So let me go back here. So I hope this also kind of give you, like, the main purpose again of Lab 0 is the environment. Get to know it, how to handle it, how to get the best usage of it, right? So hopefully this kind of covers the GitHub web page part that we didn't do in the last tutorial. Given that we have done this, I want to a little bit focus on Lab 1 and the last lecture, which is functions and defining multiple source files and header files and how things work, right? So let me see here. Okay, it seems that Aaron already passed the test as well. That's okay. Maybe I should just open my. Are you guys able to see the screen?
Yes.
Yes.
Okay, perfect. Good, thank you. So this is the starter code of Lab1, which, as you can see, is very similar to the starter code of Lab0. It will be very similar to the starter code of Lab2, and hopefully also for other labs like Lab3 and the Java labs. So this also is based on what we discussed in the previous lecture, and this is something that I want to convey to you in this tutorial is, if you have a scalable project, it's a good skill to factorize your code across different files based on what each function is doing. For example, last tutorial I gave you the introduction of how we handle the test cases with our source code and feed both to the compiler to give something. So if I let me share from my tablet here. If I go back. If I go back a little bit to what we have done and make sure you understand the test environment. So we said we have some unit testing framework, right? And then we have our source files that we develop the code on, questions.c and questions.h, and I will come into header files for now. And we feed this into the compiler and to tell us the report we have, right? So this is exactly what the concept we covered in the previous lecture, which is the same project has different files, each one of them with different target. For the test framework, what do you see? We see in our get even in your repo in Lab0, you see all tests.c, you see test cases.c, you see, I guess, all tests.h, some header files, right? So there are some files here related to the test environment. Also, you see questions.c and questions.h, right? So it's like 5-6 files, right? And the compiler knows that once you build your project, it builds everything together, right? So by splitting or by factorizing your code into specific purposes, like the files for the test are separate from the files of the development, for example, now you are able to modify each one independent of the other, right? And this is a skill you have to do. Don't write, if you are writing a big project, in Lab0 it didn't really matter, so a single line project, so it's nothing. But from the other side, we had the test framework, which is also maybe hundreds of lines of code. So if assume, for example, I was putting everything in a single file, it would be very confusing to you, right? But you had the convenience of only open the questions.c, questions.h, look into the empty add functions, add function function, and you added a single line there, right? So everything was hidden on the test side when you develop the code. And this is the factorization that I'm talking about, right? So as we said before, if the compiler is taking all of this is a compiler, how the compiler knows where to start, right? And here comes the rule of C, that you have to have one main function and it has to be only one, right? So the compiler will start from the main function and it will start calling functions as it goes, right? So this is the first thing. The second thing that we discussed in the previous lecture is header files versus source files. And I said, as a general rule, make all the definitions and the function prototypes in your header files, right? And then include the header file in your source file. And I hope you still see the screen. Okay, so I still see it here. Good. So, and then make all the development itself in the questions.h. I will give you the example of the add function because this is what we covered in previous lecture. In questions.h, you had the add function prototype. So it returns int and it takes int input 1 and input 2, and then semicolon. And we call this last lecture a prototype, which is defining, it's not really, function definition is the real implementation, but this is function prototype, right? And then in the questions.c, we went ahead and we implemented the function itself. So we said, we repeated, oh, come on. And then we repeated the function, everything here. We opened the brackets and we wrote the single file that we wanted to add the single line that we wanted to add the two variables in and return at the end, right? So this is in the source file because it's as an implementation, right? But this one, a prototype, is in the header file. Good. So this is how you should structure your code generally, right? Don't have everything. Does it mean if you have a single file of code, is it wrong? No, it's not wrong. But programming functionality is not the only important thing. And this is what differentiates a good engineer from someone who is just taking programming as a hobby, right? It's like, you don't only look into functionality, you look into the timing, and you'll see this more into SI, is that how much time you take to run an algorithm is a very important factor, right? And the other thing is the readability of your code, the scalability of your code. Good. So these things are not related to functionality. They are related more towards making your code more usable. Good. So let me see questions. I went to office hours and I have a green check mark. Okay, this is, I guess, what I was already addressed. So, okay, there are, I saw someone raising hand, so please feel free to ask if you have a question. You guys are good? Okay. Question, are we going to learn function complexity in the future? So I guess what you mean by function complexity, is algorithm complexity, like the running time complexity, I guess. ON, yeah, the O notation. So not in 2SH4, you will get this in 2SI, right? Because in 2SH4, it's more of programming rather than algorithm development. So the O notation is covered in 2SI, which is offered, I guess, next semester, which is 2SH4 is a prerequisite for. Good. Okay, so given that we kind of touched this in, this will stop, okay, yeah. And then I will go back to Lab1. So this is exactly what we do in all the labs, as I said. We factorize the code for the tests, and what I want you to understand over time is how the test environment is interacting with your own code. Good. Then in the questions.c, let's take the questions one by one and see what we are asked to do. So the main change from lab 0 into lab 1, everything would be exactly the same for the environment. The main thing is now you'll start developing somehow a more real code that implements what you guys covered in lectures, right? For example, the first question is touching multiple loop types like for, while, do, while, which we did in lecture 3. And then the second one is doing some if conditioning. So you would check if a certain input is 5-digit or not through conditions. The third one is, again, doing something you can do, use conditions or switch case, which is you take an average of a student, and based on the value, you would see what is his GPA. For example, it's between 90 and 100, you get 4, etc., etc., etc. So you have multiple if-else cases or you have multiple switch cases, both are okay. One thing that is that also it might change in when I make changes to lab 1 is this function. In fact, it might make more. Let me ask you, do you see any problem in this function? How many lines? No, doesn't matter how many lines you use in lab 1 as far as you have a reasonable code.
You're returning a float instead of an int.
Exactly, thank you. And this is the only thing? I'm also taking int as an input, right? But in fact, the average can be also a float. So these two should in fact switch, right? I should, like the average student grade can be a float. Like for example, I got 90.5, but that means it's 4, right? So I should return an int while taking float as an input. And this is something that I'm going to change today. So
we shouldn't change that.
You can change it. That's a change that if you do locally, generally you are not allowed to change function prototypes. They are given to you because the test environment is based on them. But because this is a mistake from my side, so I will appreciate if you change it internally as well. That's okay.
Okay, but so we should never, instead, unless you say it's like a mistake,
generally that's correct.
Never change headers.
Yeah, unless you are asked to also write the header, because in some labs I will give you the header template, but it's missing something, and it will say explicitly that you need to modify this one.
Okay.
Thanks. Okay, so the question, what I'm doing right now is just going quickly through the questions one by one and see if I should stop at any one of them if it requires some kind of background. So in the fourth question, it kind of covers a little bit of math, because it will ask you to, so you know that pi is an infinite number, like it's 3.14 something 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 something, so it can go infinitely, right? Because it's not a closing fraction, and there is a series that is approximating pi based on how many terms you take, and this series is given in the Lab1 document. I guess I have this open here. Can share with you as well. Okay, so this might be something good to hear. This question 4. So the pi series can be calculated as these terms, like the first term, second term, third term. And then the main purpose of this function, what you are asked to do is take an input. It's an integer input. It tells you how many parameters or how many terms you should consider in this series. For example, if your input is only 1, that means your pi will be 4. For sure, that's incorrect, right? But and a very bad approximation. This is why no one should take only a single term in this series. But this is a valid input, right? If you are asked to take 2, then your pi should be 4 minus 4 over 3, right? And then you return double, which is the value of pi. So if you go back to the lab, you will see that you are reading this. I already gave you the definition of pi as a double. You are asked to calculate this series, write the code that implements this series. I should be able to draw here. So your main purpose of this function is, or your main role in this function is to implement this series based on the value you take as an input and then return pi. Good? Okay. So some more math in question 5. So basically what you are asked to do is you are asked to find all the Pythagorean triples of a triangle within a certain range. Here is 400. So that means you are given this number as a fixed number. This is why the function doesn't take any input. Question 5 here doesn't take any input. And so let me ask you a question. If the function doesn't take any input, how many test cases we can generate for this function? What do you think? Let me see the chat here. Only one, correct, because test cases are only stimulating the input to a function, trying to stimulate different branch, would say, or different scenario of the function based on the input you provide. If there are no inputs at all, that means just a single test, right? So you stop at 400. Any Pythagorean triples of any triangle from 1, but there is no 1, basically, like 1 to 400, then you should report these, right? What you are asked to do, you are returning an int, right? So what you are asked to do is to count these. So if I go back to the lab, you will see here, you are given, can I write here? No, I can write only in Bing. Okay, so you are given the definition of the total number of triples, which you will be returning, right? And then here I'm giving you some hints on what you should do. So I'm saying you should use, for example, some treble nested for loop to calculate these things. And then each time you detect there is a Pythagorean treble, you increase your count, which is your total number of trebles. At the end, you return this. As far as this goes, that's great. There is only one extra step that you need to do, which is once you found a treble, you are also supposed to print an if statement that says, oh, I found a treble, side 1, side 2, side 3, etc. Right? Just to show you, like you will see in your console that what trebles did you find, right? Is that clear? Is there any question? A main purpose of the tutorial is try to clarify if there is anything of background that you need to know about the lab. So if you have questions, ask, right? Okay,
so
good. Yeah, sorry, go ahead, Nicole.
To take in this lab into our Eclipse, we do the same like import we did for Lab 0.
Yeah, exactly. Yeah. So yeah, this is something that is also good to confirm again, is what we have done in Lab 0 was a more of an exercise of what we should do in all labs. You have done it once, you went through all the hard times to make sure you are familiar with, but afterwards everything should be exactly like a couple of minutes, right? You import your project, you have it, you create an Eclipse project into the same folder that you have your repo in, and then you start development. So it's exactly the same step at the beginning, and also the same steps at the end. Once you finish development, or once, let me say that's a wrong statement. Once you finish development for the setting you are in, you commit and push, right? The changes you make. Thank you.
Sorry, can we already put the Lab1 from GitHub already?
Yeah, Lab1 is already there. It's starting next Monday. I have put it already 2 days ago. And the lab document is in Avenue. Similar to Lab 0 in the lab PDF here, you have an invitation link that you have an invitation link here that you click, exactly similar to Lab 0, that you just accept the invitation. It will create the repo for you in your GitHub account. You go through the same process. Good?
Thanks.
Thank you. And Lab 1 is starting this coming Monday, and it takes 2 weeks, right? And the deadline is already written in the lab document that we have open right now. Okay, let me go back to the lab and continue with the remaining questions. Question 6, count is this should be the variable that should hold the total number of found perfect numbers. Okay, perfect numbers, another math thing. So you are given, so question 6 is question 6 is the name of the function. It takes 2 inputs. And this would require you to understand, again, last lecture. So the first one is an int, and it's like dictating what is the range you need to stop at to find the perfect numbers, right? And then int perfect here is an array that we use to hold all the perfect numbers you find, right? And then int at the end is returning the count of this perfect number you found. For example, let me give you one example that we have in the document to illustrate what we mean by this. So here, assume, for example, that I provided for question 6, the question 6 input is 10, right? If you go from 1 to 10, the only perfect number you find is 6. What is a perfect number from math? Is the number that its factors sum up to the same number, right? So 6 is 2 by 3 by 1, and then if you add 2 and 3 and 1 gives you 6. So this is a perfect number, right? So if I give you your range as 10 and you start from 1 trying to find your perfect numbers, in fact you should start from 2 because 1 is not a perfect number, but anyway, if you start from 1 to 10, you only find a single perfect number, which is 6. That means your count here, your return value should be, so here, if I'm providing this as 10, this one should hold the count, which means I only found 1. And your perfect array should hold only a single value, which is 6, right? So what is written here is perfect 0 should be 6, while the count should return 1, right? If I went to like 100, for example, you would find some more perfect numbers, I guess 6 and then 28, if I remember correctly. And then perfect 0 should be 6, which is the first perfect number you find. Perfect 1 is the second perfect number you found. Perfect 3 is the third one, etc., etc., etc. Good. So that means this function, and this is a question that I have to you. That means this function is modifying this array, right? But this array is passed as an input. So how this is possible? Shouldn't I, for example, add this AND thing here to allow the function? Remember we did the scanf that we sent the address as well to allow the function to modify the input? Is there any hint about this? Do you remember this from the lecture of arrays? That we said arrays are passed by default, what we call passed by reference to the function, which means the function will be able to modify by default, right? Because the array name is in fact an address, as we will see later when we talk about pointers. The array name, which is perfect here, it's the address of the first element, right? So you are passing an address by default once you pass an array. Another thing that is important to touch in this question, we said in the last lecture, is sometimes you want to return many values, right? For example, in this function, if you found 5 perfect numbers, functions in C only return a single value, right? Here, it's a way to return multiple values by passing an array to the input and modify this array. This will allow you to return how many perfect numbers you found, like 5, 6, 7. It's a variable number, right? So again, it's another trick that you can deal with functions to allow them to modify and return multiple values at once. Good. So some of the questions in the chat is, are we allowed to change the header file? Yes, only in this case to fix question 3. And then, don't we need to define the size of the array? No. I guess, okay, that's a good question. So this takes us back to the local versus global variables, and we will continue this topic in the coming lecture. But input parameters to the function. So here we have this as empty, right? It's a placeholder that is telling you are passing an array to this function, right? Maybe it's good to touch on this, but for this I need my notes. So okay. Because that's in fact a very excellent question. So let's go back to the function that we had. I know it was question 6 if I remember correctly. It has an int. Let's say the question 6 input, and then it has this int perfect, then take this as an empty. So this question is saying, here I'm defining an array without a size, but we said in the array lecture that you have to statically define the size of the array in C, right? That's because this array, you don't define it here, right? We said it's passed by variable. So remember from last lecture, the calling function. For example, in our case, we are going to call question 6 in the test cases, right? So I'm going to call question 6, passing some input value, like 10, for example, and passing a certain array, right? This array is, I call it my, I don't know, anything, my perfect. I guess you find it called in the test cases actual, right? It's called actual array, but it doesn't really matter. You just pass it as this. So when you do this, this is function calling, right? Remember from our last lecture, this is function calling. And this is function prototyping, and hopefully we also have the definition in the .c file. When I call a function, what we said last time is the parameters are passed one by one to the input parameters of the function prototype. So the 10 will be placed in question 6._input. That means question 6_input is a variable if this is the memory space of the question 6 function. There is a variable here that is int and is called question 6_input. That is going to take the value 10 once I call it, right? On the other hand, this perfect array will not be in this memory space because I told you arrays are passed by reference, which means you only hold the address. So this array, if this is my question, assume I'm calling question 6 in the main. So here I have my main, and okay, so I have my main and I'm calling question 6 here. So before calling question 6, I have to define this array, which is my perfect. And then It's defined as 100 in the test cases, and this is an int array. And then you call question 6 as 10 and then pass my perfect. That means in this memory space, I have already defined my perfect array, right? Correct? Okay, and then now what I'm doing is just passing a reference to question 6 about this array. So if question 6 function is modifying the array, it will in fact modify directly this array in whoever called in the caller function, right? This is why you don't need to define your perfect array inside the question 6. It's already defined. If you open test cases .c, I keep switching here, but I guess I hope this is useful. So if we go into here, and then if we go into the test cases, here you find that we already define it's expected. So we define an array of 100 elements here. So we specify the type, and then we pass, this is how we call question 6 function. You pass an int value which is input, here it's 5, and then you pass the actual array, which is also 100, right? So you already define it in the caller function. You don't define it in the callee or the question 6 function itself. I hope this clarifies things, and this is very important to understand. Can you only do pass by reference with array? This is what I'm saying, is that arrays are passed by reference by default. You don't need the AND. You just give the name of the array, like what we do here, right? I'm just sending actual, right? Which is the array that I defined here. And this function question 6, in fact, is going to modify the actual array without needing to do anything extra, right? For question 6, where do we find the print statement format? The PDF instruction says that you prefer, it's already in the starter code. So it's in the question 6 itself. It tells you how to print stuff. Pointers to variables are passed by reference. Let's not talk about pointers for now. This is an advanced topic. So I appreciate that some of you are already familiar with programming, but I don't want to confuse the remaining ones. But thanks, Mark, for your note. Is there any other question related to this? So this is important to understand. So to summarize, what is the summary? The summary is any variable, like what we said in last lecture, any variable that is passed to a function, another copy in the memory of this variable is created. So whatever the function is changing will not reflect in the change of the original caller. And we gave the example in the previous lecture about X and Y and A and B. But for arrays, it's a special case. If you pass an array and you modify the array inside the function, the change will reflect in the caller function. And this is exactly what's happening here. This is a function that is calling question 6, passing an array into it, which is actual. Actual is being changed in the question 6 function to add the perfect numbers you find. And here, when you try to print actual to compare it with the expected, it will hold the values that question 6 pushed into it. Hopefully that's clear now. Okay. Good. So let's go back to the remaining questions because I don't want to. Okay, so good. What else in the remaining couple of minutes? Yeah, the last question. Question 7. So question 7 has 2 parts, and in these 2 parts, in fact, you can implement. I see some delay, but I guess can you confirm that I'm still connected?
Yes.
Okay, thank you. So question 7 has 2 parts. The first part and the main kind of paradigm that I want to convey in this question is you understand is that you can write an implementation of a function